Good morning, students. So we'll begin with the new chapter, chemical bonding. You know that when you look around, we find so many substances around us, but most of the substances, you will not find them in elemental state. Most of them they are found in the combined state. That means they form a kind of bond between them. Now, why the elements are not found in native state in nature? It is because they are not very stable. We know that the noble gases are quite stable and they don't usually form compounds. So why do the noble gases don't form compound whether other elements form? So when this was studied, it was found that whenever elements have 8 electrons in their valence shell except helium, they are found to be very stable. So that is why most of the elements they trying to attain 8 electrons in their last shell to attain stability, and that is the force, that is the driving force which compel them to react. Means how can they attain 8 electrons in the last shell? There are two options, either they transfer or they share. So depending on that we have different types of bonding. So when we define chemical bonding, how we define? The force which holds different atoms in a molecule together is known as chemical bond. This combination of two or more atoms through redistribution of electrons, this word is very important, redistribution. You see, we have used here the word redistribution. So in their outermost shell, either by transference or sharing of electrons amongst themselves so that they acquire stable electronic configuration with minimum energy, is known as chemical bonding. Remember, any reaction will occur spontaneously provided the product formed is more stable than the reactant. So after forming the product, they are expected to be more stable. Every element wants to attain the nearest noble gas configuration either by transfer or sharing of electrons. This is what we call octet rule. As you know, the noble gases except helium has 8 electrons in its last shell. Then we go to types of chemical bonding. As you can see, we have made a flow chart. There are 3 types of chemical bonding: ionic bond, which is also called electrovalent bond. Then we have covalent bond, and lastly we have coordinate covalent bond or dative bond. Now, what are ionic compounds? The ionic bonds are formed, as the name suggests, you can understand they are formed by ions. Now, how ions are formed? Ions are formed either by loss or gain of electrons. So, when elements lose electron, they attain positive charge, we call them cations, and when they gain electron, then they form anions which are negatively charged. Now, this being oppositely charged, they attract each other by electrostatic force of attraction, which is also called Coulombic force of attraction, and that's how the atoms are held together. Now, how do we show the formation of ionic bond? Kosel and Lewis, they have shown some method by which we can explain the formation of ionic bond. You can see here it's written Kosel-Lewis approach. Ionic bonds are formed between highly electropositive and highly electronegative elements, that is, elements belonging to the extreme left and extreme right of the periodic table. Please make a correction here, this left should be right. But remember, though in the extreme right we have the noble gases, we are not considering the noble gases. That means elements of group 1 and 2 and elements of group 16 and 17. Usually this combination they form ionic compounds. Now we take some examples. You see the highly ionic compound is NaCl. So Na, when we look at the electronic configuration, it is 2, 8 and 1. Now we can see valence shell of sodium contains 1 electron. So there are two options for sodium, either by losing one electron or by gaining 7 electrons, it can form octet. Now which one is easier, losing one or gaining 7? Definitely losing one is easy. So sodium loses one electron and we write Na plus because it lost one electron, and E. Now loss of electron, as you know, is defined as oxidation, so it is a kind of oxidation reaction. Now the electron lost by sodium will be taken by something. So here the counterpart of sodium is chlorine, which is having an electronic configuration 287, and it has 7 electrons in the valence shell, so it gladly accepts one electron and it forms Cl minus. Now by convention we do not write minus electron. Nowadays the modern convention says that the electron should be always written as plus electron. That is why we have not written sodium, and we did not write here we did not write minus electron. Okay, we wrote plus electron in the product side. So when we add up the two steps, electron and electron get cancelled and we have Na plus Cl giving you Na plus Cl minus, which in turn forms NaCl by force of electrostatic force of attraction. Next we move to calcium oxide. Calcium is having electronic configuration 2882, so it has having 2 valence electrons in the last shell. So it prefers losing 2 electrons to attain the octet. So you can write Ca2 plus having electronic configuration 288 plus 2 electron. Oxygen having electronic configuration 26, so it accepts 2 electrons to attain octet and it forms O with 2 negative charges. Remember, as many electrons they lose or gain, accordingly they will have the charges. So here also number of electrons are equal, so they get cancelled when you add up the two steps. The first step is oxidation, the second step is reduction, because gain of electron is reduction, and we get Ca plus O giving you Ca2 plus O2 minus giving you CaO. Next we move to magnesium chloride. You see, magnesium is having electron 282, so it just like calcium, it also loses 2 electrons and form magnesium 2 plus having the configuration 28. Now chlorine, it has 287, that means 7 electrons in the valence shell and its requirement is only 1. So it will take 1 electron and it will form chloride. Now when we compare the two steps, you can see magnesium lost 2 electrons but chlorine accepted only 1. So where will the other electron go? The other electron, to equalize the other electron, we have to multiply the entire second equation by 2. So you can see here we have multiplied and we wrote 2Cl plus 2 electron and 2 chloride. Now if we add up the two steps, then the electrons being equal, they get cancelled off and we get Mg plus 2Cl giving us Mg2 plus 2Cl minus, and the product formed is MgCl2. Now here I would like you to draw your attention, when you write the equations, try to write in such a way that the position of the arrows is just one below the other. Don't change the position of the arrows. There is no harm actually, but it doesn't look good and it creates confusion while doing the corrections also, and when you write the equation and add up, then also it might create some confusion. So I have given you some homework, MgO, which is very similar to CaO. Then I have given you CaCl2, which will be very similar to MgCl2, and lastly you have to do Al2O3. I hope you can do it on your own. Now how to know whether a given compound will form ionic compound or not? There are a few factors which determines the tendency of ionic bond formation. First of all, you see sublimation energy. I go back to the previous equation. You see here we have written Na plus Cl giving you Na plus and Cl minus, and Na is losing electron and Cl is gaining electron. Now we know that normally metals are available in the nature in solid state and halogen Cl is present in the molecular state. Then how does the reaction occur? You know that the metallic sodium or any metal has to be first converted to a gas, and the process is called sublimation. And we know solid to gas will involve absorption of energy. You know matter exists in 3 states. So solid to gas, when you want to convert, it will be an endothermic process, and that's why you have written delta H sublimation to be positive. Now lower the amount of energy you require to convert them to gaseous state, more will be the tendency for ionic bond formation. If you require a lot of energy to convert them to gaseous state, then it will not be a favorable condition for ionic bond formation. You can see we have written here, lower the enthalpy of sublimation, more is the tendency of ionic bond formation. Okay, so now you got the metal in the gaseous state. Now the metal has to lose electron. We have represented the metal in general as M. Now you know that metal, when they lose electron, they have to overcome the force of attraction due to the nucleus, and this energy is called ionization energy. How we define ionization energy? It is the amount of energy required to remove the valence electron from an isolated gaseous atom. So the metal has to be in the gaseous state before it loses electron. So I have written over the arrow IE, which stands for ionization enthalpy, and it is also absorption of energy, that is endothermic in nature. That's why it is also positive. So since it is positive, so lower the ionization enthalpy, more will be the ease of ionic bond formation. Now how does ionization enthalpy vary across a period? Say if I compare sodium and magnesium, which one will lose electron more easily? You know that ionization enthalpy increases across a period. That's why sodium will lose much easily because its ionization enthalpy is less, and magnesium will be losing electron with little more difficulty. So sodium has more tendency to form ionic bond compared to magnesium. So as you keep on increasing across the period, as you keep on moving across the period, the tendency of ionic bond formation by the metals will keep on decreasing. But when we go down the group, if I compare sodium and potassium, you know sodium is having smaller size and potassium is having bigger size because of its number of shells. More is the number of shell, more is the radius, and more easily it can overcome the force of attraction due to nucleus. As a result, potassium will have more tendency to form ionic bond compared to sodium. So all these you have to understand. Next comes bond dissociation enthalpy, that is for, and we have represented it by Be. The symbol Be is used to express bond dissociation enthalpy. Now as you know, most of the nonmetals, be it chlorine, fluorine, oxygen, nitrogen, they all exist in the molecular state in nature. So first you have to break their bonds, otherwise you see here chlorine is we have taken in the atomic state, isn't it? The chlorine we have taken in nature, chlorine exists in the molecular state. So you have to first convert the nonmetal to its atomic form. So you can see here we have broken the bond, we have broken the bond, XX bond, and the energy involved in breaking the bond is Be, and we get atomic nonmetal in the gaseous state, and this is also positive because it is also involving absorption of energy and it is endothermic in nature. So lower the bond enthalpy, more is the ease of ionic bond formation. So you got the nonmetal in the gaseous state. Now the nonmetal has to gain the electron. Now nonmetals, since they are electron deficient, they would like to accept the electron, forming an anion in the gaseous state. And here the amount of energy involved is called electron affinity. How we define electron affinity? It is the amount of energy released. Remember, it is the first case here we are encountering where the amount of energy is released. So it is exothermic in nature. It is the amount of energy released when an electron is added in the valence shell of an isolated gaseous atom. Now, since it is exothermic in nature, higher the electron enthalpy, more will be the ease of ionic bond formation. So you got the metal in the positive state, you got the non-metal in the negative state, but now remember both are in the gaseous state. But when you take sodium chloride, which you get in the market, that common salt which you are taking, are you eating them in the gaseous state or you are taking them in the solid state? I am sure you are taking them in the solid state. So when the positive ion and the negative ion, due to force of attraction, they come closer, lot of energy is released during the process, and that energy is called lattice energy. So it is the amount of energy released, again remember this is the amount of energy released when appropriate number of gaseous ions, positive and negative, are brought to their equilibrium position. That means there is a minimum distance by which they could be brought closer. You cannot make them touch one another, because in that case they will suffer repulsion. Remember, though they have lost electrons from the last shell, but still there are electrons in their inner shells. So electron of one atom and electron of the other will start repelling if you bring them very close to each other. And not only the electrons, even the nucleus of one atom and the nucleus of the other atom will start repelling if you bring them very close to each other. That is why they can be brought only up to certain distance, which is called equilibrium position, in the crystal lattice. As you will do solid state in class 12, all these crystal lattice and all you will study in detail, which will be taught by Sir. So M in the gaseous state, M plus in the gaseous state and X minus in the gaseous state, they form Mx in the solid state, and during this process lot of energy is released, and that's why delta H is negative. So higher the magnitude of the lattice energy, greater is the tendency of the ionic bond formation. So in general, you can remember, whenever the process is endothermic, lower the value, better it is. Whenever the process is exothermic, higher the value, better it is for ionic bond formation. So that's all about the various factors which decide the ease of ionic bond formation. So to summarize, you can see we have written ionic bond formation is inversely proportional to ionization enthalpy, inversely proportional to sublimation enthalpy, inversely proportional to bond enthalpy. If you notice, they were all having positive sign, and they are directly proportional to electron affinity and lattice enthalpy, because the energy was released and they were having negative sign. So that is all about ionic bond formation and their factors. Now we have to do the properties of ionic bond formation, which you can do from your book, or I'll try to send you the note also. So that's all for today.